Okay, so let's begin then. So let's start with a few more concepts. We'll do some practice today on whatever we've learned until now as well. And then in the next class, we start with algebra. But today we want to do some practice from the works that are uploaded as well. I hope you've attempted some questions from that at least. Hopefully all of them, because it was fairly straightforward. There wasn't really much complication. But there's still a few things that we want to discuss from this topic. And that is what I'm going to start with today. So first of all, this is a major thing. Board mass, let's discuss this very quickly because a lot of people end up doing careless mistakes when they're adding, subtracting, dividing, multiplying numbers because they're not careful about these rules. So let's start with this. 45 questions, that's really good, Fatima. So that's what is required throughout. A lot of practice, and you will be fine, inshallah. All right, so let's start with this. So whenever you have to add or subtract fractions, you have to be careful about the order in which you apply different operations. So BOD mass, this is basically an abbreviation or an acronym for 6 different types of operations that you can apply on any numbers, any expressions. First of all, B is for brackets. And you can have different types of brackets. You can have the round brackets, curly brackets, square brackets, right? Now, you have to make sure that you start with the innermost brackets. Whatever is the innermost bracket, you evaluate that first of all, and then the bracket outside that, and then the bracket outside that. So you have to start with this has the highest priority. So the priority is in this direction. You start by evaluating brackets first of all, and then O stands for order. Now, what does that mean? It basically means two things. Primarily, it means two things. It means any exponents, or you can say powers. So if you have something in power, right, like this, for instance, 2 cubed, you have 4 squared. This has more priority. You have to evaluate this first before you do any addition, subtraction, multiplication, division, etc. Okay. And order also includes functions. So when you have a function applying on a number, on an expression, for instance, in your syllabus, you will see sine, you will see cos, you will see tan. This also comes here. You cannot do multiplication, division, addition, or subtraction before you have evaluated sine, cos, tan, etc. Now, later on, you will see other types of functions as well. For example, you'll see ln function, that's the log function. You will see, for instance, tan inverse, sine inverse, cosecant, chord, a number of different types of functions. So basically, the idea is if you have any function applying, that has the second priority. Okay. So number one, brackets. Number two, order that includes exponents, that means powers, and any functions that are applying. Okay. Number three, and at number four, they have the same priority basically. So division and multiplication, they have the same priority. There's no difference between the two. And addition and subtraction, they have the same priority as well. As in, you can do division first or multiplication first, it doesn't matter. And you can do additions first or subtraction first, that also does not matter. So at number three and at number four, you've got division and multiplication. Okay. Between them, it doesn't matter which one you do first. And at number five and at number six, you've got addition and subtraction. Between them, it does not matter which one you do first. Okay, so this is the order that you're going to follow when you're going to apply any operations. Now, even though the order between addition, subtraction, and multiplication and division does not matter, as in between them, the order does not matter, you have to go from left to right. So this is a very important point that you need to keep in mind. For operations having the same priority, for example, if you have division and multiplication, or if you have addition and subtraction, you go left to right. You go left to right. Now, what do I mean by that? For instance, if you've got something like this, let's say you have 3, or let's take a bigger number. Let's say you've got 10 divided by 4, or let's say 10 multiplied by 4, and then divided by 2. If you've got something like this, you have to go left to right. Okay, you've got to go left to right. So you do 10 into 4 first of all, and then you do 4, whatever the result is, you divide that by 2 afterwards. Okay, so you have to go from left to right. Okay, so in this case, for instance, we'll do something like this. We'll go 10 into 4, and that gives us 40. The divide by that by 2, and that gives us 20 as the final result. Now, in this case, it actually does not matter. Even if we were to do division first, in this case, it would not make much difference. But for instance, if you had something like this, if you had 5 minus 4 plus 2, if you have this, you cannot do it like this, that you say you're adding 4 and 2 first. That would not make sense. You cannot do this thing first and give 5 minus 6 and then minus 1 as the final answer. That would not work. This would be incorrect. Okay, so addition, subtraction and addition, even though they have the same priority, you have to go left to right in them. Okay, you've got to go left to right. So the correct way of evaluating this expression would be that you first of all do 5 minus 4. What does that give you? That gives you 1. And then you do 1 plus 2, and that results in 3. And that's the correct result. So for numbers having the same priority, for operations having the same priority, you go left to right. Okay, you go left to right. Now, let's take a bit more complicated expression in which we have got multiple operations applying. If you have, for instance, 5 plus 7 multiplied by 2 minus 3 multiplied by 6, how is this going to work? Remember BODMAS. So between multiplication, division, addition, subtraction, multiplication and division are supposed to be done first. So you have to do this thing first, and you have to do this thing first before you can do plus or minus. Okay, so you evaluate it like this. You say this is 5 plus 7 times 2, that is 14, and then minus 3 times 6, that is 18, and that's going to give you a result. You can see what that is. That's 19 minus 18, which is 1. Okay, so addition, multiplication, division is supposed to be done first, and then after that, you do addition and subtraction. All right, I hope that makes sense. If you have brackets involved or exponents involved, let's say you've got something like this, 2 raised to the power 3 multiplied by 2 plus 4 multiplied by 3. Okay, so I've got something like this now. How do I evaluate this? If I also have a bracket here like this. Now, according to BODMAS, what has the highest priority? What's the highest priority? Brackets. We have to evaluate bracket first, Even though we've got multiplication here, we are not going to do 4 into 3 yet because of this bracket. So we cannot do multiplication first. Okay. Inside the bracket, so let's see what's happening inside the bracket. Let's evaluate everything that is inside the bracket first of all. Inside the bracket, we've got three things happening. We've got three numbers. And how many operators do we have? We've got multiplication, we've got addition, we have a power. What's the highest priority amongst these? Power, right? Order includes power. We have to evaluate the power first of all. So when we evaluate the power, it is going to give us 3 times 8 plus 4 times 3. So 2 raised to the power 3, that becomes 8 first of all. That's the first thing that has to be evaluated inside the brackets. And now inside the brackets, we've got multiplication. So we have to do multiplication next now. 3 times 8, what does that give us? 24. 24 plus 4 multiplied by 3. Again, inside the brackets, we've got 28. Once the bracket is evaluated fully, now we can do this outside multiplication. 28 times 3. What's that? That's 56 plus 28, which is going to be 84. This is the result that we get from this. Okay, you have to be very careful about indices. A lot of people sometimes end up doing mistakes like this through their A levels as well. So if they have something like this, for instance, 6 times 3 raised to the power x, they would write it as 18 power x. You cannot do that because remember, what has the first priority? Indices have the first priority. You cannot do multiplication before you've evaluated this power. Okay, before you have evaluated power, you cannot do multiplication. It cannot be like this. Okay. So what do we do with this? Unless we know the value of x first, we can do something. So in this case, for instance, if we had 3 raised to the power 2 here, we cannot do 18 power 2, right? That would not work. What would be the correct way of doing this? You would say 6 into 3 squared, that evaluates to 6 into 9, and then that gives you 54 as the final result, because you have to evaluate the power first and then do something else after that. Okay, and then you will see other kinds of operators later on as well. For example, as I said, you might have sine, cos, tan, functions like that. What happens when you have those functions applying? So for instance, if you have sine of 30 multiplied by 7. Now, what does that mean? Sine 30 multiplied by 7. Can we write it as sine of 210? No, that would be wrong. We cannot do this multiplication because remember, BODMAS, what does that say? O comes before multiplication, right? So we've got these two operations, order and multiplication. Order, which means function, has to be done first, has to be applied first. So sine 30 will be evaluated first before you can do anything else with that. So if you have sine of 30 multiplied by 7, sine 30 will evaluate to 1 over 2. You can do that on your calculator. Multiplied by 7, and that is going to give you 3.5 or 7 over 2 as the final result. Okay. Similarly, if you have a number multiplying before, it's the same thing as this. If you have, for instance, 5 times tan of theta, this is not the same thing as tan of 5 theta. Okay, you cannot do this multiplication first of all because you've got theta here. And if you have anything else apart from theta, for instance, if I had tan of 10 here, let's say, we cannot make it tan of 50, right? Because unless you evaluate tan of 10 first of all, you can't multiply this 5 inside. That would be wrong. Okay. I hope that makes sense. Now, This is what you need to take care of when you are applying any operations. Now, when you are applying operations on negative numbers, a lot of people have some confusions there as well. So let's talk about that, how to deal with negative numbers. You have to be very careful about negative numbers because a lot of careless errors happen when you're dealing with them. For instance, if you have something like this, if you have minus 4 squared, now what should that give you? Minus 4 squared. What should this result in? Any idea? Minus 4 squared? What should you get from this? Minus 4 squared. Compare that with minus 4 whole squared. These are two different things. Yes, that's good. So minus and square, which has the higher priority? The square. So square will be evaluated first. You'll have 16, and then you have the minus put with that. However, if we have brackets here like this, brackets have a higher priority, right? So brackets will be evaluated first before you can do the square. What that means is the square is on this whole thing now. The square is not on just 4. The square is on minus 4. And when you have a square of minus 4, what does that mean? That means you're doing minus 4 times minus 4, and that results in 16. Okay, so you have to be very careful when you have brackets here like this. Similarly, when you're adding or subtracting negative numbers, for example, if you have minus 11 plus 4, let's say, how do you do this? Number one, you have to go left to right. So don't do it like this, at least, that you say it's 11 plus 4 first of all, and then minus 15. That is obviously wrong. An easy way of thinking about these is that you reverse them. If you get confused by this, it might be easier if you write it like this first, 4 minus 11, and then that becomes minus 7. If you have two negative numbers, if you have minus 4 minus 2, for instance, think of it like you're adding the digits. 4 and 2, you basically add both of them. What does that give you? That gives you 6, and then you write minus 6 there. So kind of in our head, we're thinking like this. We're saying minus, and then you have taken minus common, and inside you're left with 4 plus 2. So you've got minus 6 there. When you have numbers like these, in which one of them is negative and the other is positive, the result will be the sign of the bigger number. Whatever is the bigger number, that is going to be the result. So in this case, for instance, minus 11 plus 4. So let's actually do some more examples of this first. You got minus 11 plus 4. What's the bigger number? The bigger number is 11. So the sign that you have with the result is of the bigger number. If you have something else, for instance, like this, if you have minus 2 plus 7, now in this case, the bigger number is 5. So the result is going to be positive in this case. If you have 16 minus 19, the bigger number is 19 in this case. The result is going to have a negative sign there, and that's going to be negative 3. If both the numbers are negative, what happens in this case? As I said, we add them up together and put the negative sign there. All right. If both are positive, of course, the result is also going to be positive. So in addition, subtraction, if both numbers are negative, the result is negative. If both numbers are positive, the result is positive. And if one is negative and the other is positive, the sign that you have at the end is of the bigger number, right? So in this case, for instance, if we had 6 plus 4, that will just be 10. Now, that's the easier part where you just have to do addition, subtraction. Sometimes what you have to do is you have to multiply or divide negative numbers. Now, in that, remember the rules. When you have two positive numbers multiplying, the result is always going to be positive. Positive into positive, the result is going to be a positive number. When you have a negative number multiplying by a negative number, negative times negative, the result is going to become positive. Okay. On the other hand, if one of the numbers is positive and the other is negative, or the first is negative and the second is positive, the output that you get is going to be negative. Okay. So both positive and both negative, the output is positive. If one is negative and the other is positive, the output is negative. So did I say that correct? So if both are positive or both are negative, the output is positive. And if one is negative and the other is positive, the output is negative. All right. For instance, if you've got something like this, -2 times 4, you're multiplying these two numbers. One is negative and the other is positive. 2 times 4 is 8, but since you've got one negative, the answer is -8. If you have -5 into -4, 5 times 4 is 20. And since you've got both negative numbers, the result is positive, right? Negative and negative kind of cancel each other out. If you have -6 over -2, 6 over 2 is 3. And since both numbers are negative, the result is positive. And if you have 15 divided by -3, one is positive, the other is negative, the result is going to be negative as well. So if you've got both positive numbers multiplying, the result is positive. If you've got both negative numbers multiplying, the result is again positive. If one is negative and the other is positive, the result is going to be negative in this case. Okay. Now, pretty straightforward stuff. And I hope you are already familiar with this, but that's important for the sake of completeness that you do need to know about this as well. All right. No problem until this point. So just a couple of other small things before we move on to actually attempting some questions from that worksheet. So you can also let me know in the chat box if there are any specific questions that you found difficult or you were not able to do, and we will have a look at those questions in particular from the worksheet. Otherwise, I'll be choosing some questions myself, which are kind of tricky. All right. Okay. Now, another type of problem that you often see, if you have attempted the worksheet, you would have seen problems like these, for instance. Let me find one like this, where they talk about difference between two numbers. So sometimes they would say something like this: find the difference between, let's say, 15 and 21. Find the difference between 15 and 21. Now, what is this going to be? Difference between 15 and 21. Do we just do 15 minus 21? Because that is going to be -6. No, whenever they ask about difference, the result is always going to be positive. So you always do the bigger number minus the smaller number. So what's the bigger number here? The bigger number is 21. You subtract from that the smaller number, which is 15. So 21 minus 15, that is 6. You always subtract the smaller number from the bigger number. That's what you always have to do. Now, in this case, it was fairly straightforward. It becomes a bit confusing when you have two negative numbers, for instance. So let's say you want to find the difference between some negative numbers. You've got -17 and -25. Now, what do we do with this? What's the difference between these two numbers? Since both are negative, it's easier to just think of the difference as positive. So let me actually do it the proper way first, and then I'll share with you a direct way of doing this. So in this case, as I said earlier, you do a bigger number minus the smaller number, right? Okay, what's the bigger number? Since these numbers are negative, in negative numbers, the number that has a smaller magnitude is the bigger number. So 17 is a bigger number, minus 17 is a bigger number. So you do minus 17 minus 25, and then that gives you minus 17 plus 25, and the result is 8. Okay. Now, since we know that we are always going to be subtracting the smaller number from the bigger number, that means the result is always going to be positive, right? We can directly just subtract 25 and 17 here as well, right? Rather than thinking of the negative numbers, we can just do 25 and 17. 25 minus 17, that's 8. Since both numbers are negative, the gap between them is going to be just 25 minus 17, and that's 8. You can just skip the negative part, and that's perfectly okay. However, if one of them is positive and the other is negative, in that case, you do have to consider the negative sign. For instance, if you have to find the difference between minus 2 and 7, in this case, the bigger number is 7. You subtract from 7 minus 2, and that gives you 7 plus 2, which results in 9. That's the result. Now, you see, the result should always be positive. The answer, the final answer that you get is always going to be positive. So whenever you find difference between two numbers, keep in mind the final result is supposed to be positive. Okay? Let me write that down here as well. For finding the difference, between two values, what you have to do is subtract from the bigger number the smaller number. Okay, that's always what you have to do. And the result will always be positive. The result will always be positive. Okay, you cannot have a negative result from this. The result should always be positive. Okay, I hope that makes sense. Again, a fairly simple thing. Now, sometimes you have to order numbers. Okay, that's another type of question that you must have seen in the worksheet. Let me take one example. So let's say you have to order these numbers. So let me see if I can actually open that. Something. Okay, I'll just write it down. I have to find that otherwise. Okay. So let's say we've got a set of numbers like this. 13 over 20, and you've got 0.7. You have 7 over 12. You have 0.64 and 5 over 8. You've got this the set of numbers. And what you want to do is you want to order them. You want to arrange these numbers from smallest to largest. Okay. Now, how do you order these numbers from smallest to largest? Now, in order to be able to compare numbers, they should be of the same form. You should either have all of them as fractions or have all of them as decimals. If you want to have all of them as fractions, to be able to compare them easily, you would need to have the denominators the same as well. Okay, because if the denominators are not the same, then the comparison is going to be difficult in that case as well. Now, how do we arrange these numbers? As I said, we either want all of them to be decimals or all of them to be fractions. Now, the problem with converting them with fractions, so generally what we try to do is whatever is the bigger number, for example, we've got 3 fractions. it might have been easier to convert all of them to fractions because only two numbers are left that are not fractions. You can convert those two numbers to decimals. That is one idea. The other idea is, sorry, convert those two numbers to fractions, right? That's one idea. The other idea is that you find the decimal value of these fractions somehow. Once you have that fraction, once you have that decimal value, then you try to compare the numbers. So you do one of these two things. Okay. Let's see what happens if we try to convert everything to fractions. Okay, that could be one idea, that we convert everything to fractions, right? Okay, now the first one is already fraction. Okay. What about 0.7? We could write that as 7 over 10, for instance, right? We have one decimal, so we can say that 7 over 10 with 1 0. 0.64, we've got two decimals there. We could do 64 over 100, right? We've got two decimals, so we have two zeros in the denominator there, and that gives us the result. Okay, so now we've got these fractions. How do we compare these fractions now? To be able to compare these fractions, we need to have the same denominators. Okay, we need to have the same denominators. If we can convert them to a form such that they have the same denominators, then we would be able to compare them. Okay, now how can we have the same denominators? We've got 10 here, we've got 100 here. This one, for instance, the 21, if we multiply this by 5, what do we get from that? This is going to be 65 over 100. Okay, this can be 70 over 100. So we've got 100 for three of them now. The problem is 12 and 8, they are not really divisible by, so 100 is not a multiple of 12 or 100. But we can try to do something to estimate this as well. Let's think about it. So 7 over 12. What's, if we convert it to 12 times 5 is going to be 60, and then we could say 12 times 5. Let me just do it that first. If we do it like this is going to be 35 over 60, first of all. And now, if you can add another 0 there, that becomes 350. Okay, so now we've got 600 in the denominator. Okay. Now, you can either divide 350 by 6 and see approximately what that number is going to be. Okay, divide 350 by 6. What do you think that is going to be? 350 divided by 6. It's going to be 50 something, right? Because we know that 30 over 6 is 5. 36 over 6 is 6. This is going to be a number that is somewhere between 50 and 60. And it's going to be closer to 60. So maybe somewhere around 57, 58. So if we divide the numerator and denominator by 6 here now, that is going to give us approximately 50 over 100, 58 over 100. And that is going to suffice because there are no other numbers that are close there. So this is enough approximation. And now we should be able to compare this as well. Okay. And then finally, we've got 5 over 8. Again, if we want to take 8 to somewhere around 100, we think of how we can take it to a multiple of 100. So for instance, if we add 1 0, what do we get there? We get 50. 50 over 80. If we add another 0, we get 500 over 80. And now we can see what 500. So since we want to make 800 100 now, we can do 500 over 8 there. What would that be? 8 times 5 is 40. 8 times 6 is 48. You can do it on the side here, 500 over 8, and see what that is. Okay, 8 times 6. So we've got 6 there. We've got 48, and we've got 20 left. 8 times 2 is going to give us 16 there. And we've got 4 left. And we add another 0 here. That's 40. And we have 5 here. That's going to be 62.5. That is what we get here. So this number turns out to be 62.5 over 100. And now we can compare them. We can compare the numerators, see whatever is the smallest number. What's the smallest number out of these all? The smallest number is 58. Then after that, we have 62.5. Then we have 64. And then we have 65. And then we have 70. So when we order them, we have to write down the original numbers. And that's going to be 13 over, sorry, the smallest number out of these all is 58 over 100. Then the second one is, I'm sorry, this is number 1. We have to write it on top here. This is number 1. This is number 2. It was originally 5 over 8. And then this is number 3. This is number 4. And this is number 5. Let's write them down. 7 over 12. And then you have 5 over 8. And then number 3 is 0.64. And number 4 is 13 over 20. And number 5 is 0.7. You write these numbers down like this. And that's the order that you were looking for. Now, this took quite some time, right? Converting them to fractions. All of them, since finding the LCM here would have taken a lot of time for all these numbers. Converting them to common denominator was kind of very time-taking, okay? Especially the 7 over 12 was tricky. Let's see if we could do it quicker if we converted it to decimals. That's another idea, that we convert everything to decimals. Let's try doing it that way now. So we've got the same numbers again. And what we want to do is we want to sort them. We want to order them from smallest to largest. Okay. Now, since the denominators of these numbers are all different, as I said earlier, converting to decimals might be slightly quicker here. We've got 2 numbers that are already in decimals, and the others are fractions. Can we convert the fractional numbers to decimals somehow? What about 13 over 20? Remember what we did for this? We said we would want the denominators to be some power of 10. We would want it to be 10 or 100 or 1000 because that will make things easier to compare. Can we make the denominator one of those? In this case, for instance, we can do something like that. We can say it's 13 times 5 and 20 times 5, and that gives us 65 over 100, and that becomes 0.65. So this has been converted to decimals. We already have 2 decimals in that list, so they are going to be easy to compare. What about 7 over 12? How do we convert this to decimals now? 12, can we try to somehow take it to a power of 100, a power of 10? That means either 10 or 100 or 1000. Now think about it. Do you have 100 or 1000 in 12 table? You don't, right? 100 is not a multiple of 12. 1000 is not a multiple of 12. So it's going to be hard to convert it to 10 or 1000 or 10 or 100 or 1000. It's going to be hard to convert the denominator to that. That means you'll have to use decimals somehow. Now, this is how you can try to think about it. Think of 12's table. 12 times 5 is 60, times 6 is 72, times 7 is 84, times 8 is 96. 12 times 8 is what? 96. 12 times 9 is what? 108. Where is 100 going to be? 100 is 4 away from 96 and 8 away from 108. If you see the ratio, what is the ratio? 4 to 8? It's 1 to 2 ratio. That means from 96 to 108, if you divide this into 3 parts, this is where 100 is, this is where 104 is. 96 is coming when you multiply 12 by 8. 108 is coming when you multiply 12 by 9. And 100 is coming at this place. So you're converting it to 3 different parts, right? 1 part, 2 part, and 3 part. Now, these are some common decimals that you should actually keep in mind. Let me write this down here. 1 over 2, for instance, what's that? That is 0.5, right? That's easy to remember. 1 over 4, for instance, is 0.25. 1 over 5 is 0.2. But there are some recurring decimals that you should remember as well, which will be very helpful for your mental math when you're attempting problems like these. 1 over 3, for instance, what's that? You will need to remember this because you will not have calculator available in one of the papers, right? 1 over 3, what is that estimate? Or what's the estimate for that? It's 0.33333, right? That's what it is, 1 over 3. Similarly, if you had 1 over 6, what would that be? Just half of this, right? That's like 0.1666666, and it's a recurring decimal like this as well. Now, keeping these in mind will really help with your estimation. Now, in this case, for instance, we said we've got 8 here and we've got 9 here. And if we're divided into 3 parts, 1, 2, 3, one of these parts is what is going to take us to 100. So this is going to be 8.33, 1 out of 3, right? So this number is going to go like this. If we want to convert the denominator, to 100, what do we have to multiply it by? We have to multiply it by 8.333. Okay? We have to multiply the denominator by 8.333. Now, that means we have to multiply the numerator by the same number as well. So we multiply the numerator by the same number, 7 into 8.333, 7 times 8, what's that? That's 56. And then you add some more. So 7 into 8.333, 7 times 8 is 56. And then 0.33, that means 1 over 3 times 7, 0.333 times 7, you need to add that more. That's going to be 2 point something, right? So it's going to be somewhere around 58, right? So it's close to that. It's going to be around 58. We can estimate that, right? Because 7 times 8 is 56, 7 times 9 is 63, 8.33 is kind of close to 56, 58 or 59, it's going to be around about that. Okay, so you can say 58 over 100, and that converts to 0.58. And then similarly, 5 over 8, you can do something similar to this as well. How can you take it to 100? Is 100 a multiple of 8? Well, it's not. However, 1000 is a multiple. You can either take it to 100 if you think you can do that, because 8 times 10 is 80, 8 times 11 is 88, 8 times 9 is 90, 8 times 12 is 96. 8 times 13 is 104. Now you see 100 is exactly in the middle. If it's exactly in the middle, that means 12.5 is going to work. 12.5 in the denominator and 12.5 in the numerator. That means if we multiply by 12.5 in the numerator and in the denominator, we can convert the denominator to 100. Now, what's 5 into 12.5? Do 5 into 12, that is 60, plus 5 into 0.5. So basically half of 5, what's that? That's 2.5. That's going to be 62.5. And this can then be written as 0.625. And now you can compare these decimals. You've got 0.65, you've got 0.7, you've got 0.64, which is the smallest. The smallest is this one, number 1. And then the next one is this, number 2. 6.4 is number 3, and then number 4 and number 5. And as earlier, when we write them down, we have to write down the original numbers. The original numbers are 7 over 12, and then we've got 5 over 8, and then we have 0.64 and 13 over 20 and 0.7. Okay, now this was a relatively tricky one on ordering. Mostly it's a lot simpler than this, because in this case, there were two fractions which were hard to evaluate, 5 over 8 and 7 over 12. These were the harder fractions to evaluate. Mostly, it's much simpler than this. For instance, here's another example. If you had 3 over 4 and 0 and -1 and minus 17 over 20, and let's say you've got 4 over 5. You've got this list. Again, what you want to do is you want to arrange them smallest to largest. Now, this is much easier to do because in this case, the fractions are easier to estimate. You've got 0, -1. What's 3 over 4? How do you do that? Can you convert this denominator to 100 somehow? You can multiply this by 25, multiply the numerator by 25 as well. And that is going to give you 75 over 100, and that is 0.75. It helps to remember 3 over 4 as well. 3 over 4. 1 over 4 is 1.25, right? 2 over 4 is 0.5. 3 over 4 is going to be 0.75. Since it's a very common fraction, it helps to remember this as well. Then the next is 0, -1. They're kind of obvious. What about this one? 20 is what you have in the denominator. You can multiply that by 5. So multiply both the numerator and denominator by 5. And that's going to give you minus 85 over 100. And that evaluates to minus 0.85. Okay. And then 4 over 5. What's that going to be? If you want to do it like this, you can multiply by 2, both the numerator and the denominator. And that's going to give you 8 over 10. And that evaluates to 0.8. Now, what's the smallest number? -1 is the smallest number, and then minus 0.85, that's the next one, and then 0, and then number 4 is 0.75, and number 5 is 0.8. That was much simpler, and you've got -1, minus 17 over 20, 0, 3 over 4, and 4 over 5. That's what you write as your final answer there. Okay. So you have to convert everything to the same type of number. Once you have that, then that will work. Is that okay? Any confusion here? Any problems? Okay, now we could have a look at some questions from that worksheet. Then just one small pointer before we do that. I was just looking at the worksheet again, and there is one small thing that you might need to know for that as well, and that's conversion between decimals and percentage. So that's something that you have to do sometimes as well, percentage and decimals. You can convert it to decimal or a fraction as well. Okay. Now you should be able to do it both ways. So for instance, if you've got 36%, percent, what does this mean? Percent, the word itself basically means percent. Cent stands for 100. It means per 100. Okay. So whenever you have a percentage sign, what that essentially means is you've got 36 over 100. So this percentage sign means over 100. So if you had to write this percentage as a decimal, that would be 36 over 100, which means 0.36. Okay. And if you had a decimal and you have to write that as a percentage, if you're going towards the right side like this in this direction, percentage to decimals, what you do is you basically divide by 100 over 100, right? If you had to do the other way around, for example, if you have a number like this, if you have 0.137, you want to convert it to a percentage. For that, you multiply it by 100, right? So 0.137 multiplied by 100, what does that give us? The decimal places, the decimal shifts 2 units to the right, and that gives you 13.7%, right? This is percentage. And if you had to convert it to fraction, that would be 137 over 1000. Okay. You have 3 decimals. You have 3 zeros in the denominator because of that. So this is what the fraction would look like. And for percentage, you multiply it by 100. Okay, so that's something that you also should be aware of. Now, let's have a look at some questions from the worksheet quickly. One question that there was a problem with was 33. Okay. Let's have a look at that. Question number 33. Okay, what was the problem with this? Question 33. Let's try this. Okay. Just share this file here quickly. Okay, question number 33. Let's try this quickly. Okay, so how do we evaluate this? 52.3 times 10 minus 3.76 into 100. Is that what you're asking about? Okay, so what do we do first? Multiplication. So multiplication has to be done first, right? 52.3 times 10, what's that? That's 523. This multiplication has to be done first. You've got 2 decimals, 2 zeros. So the decimal will shift 2 units to the right, 2 places to the right, and that gives you 376. Then now you have to do the subtraction. 523 minus 376. You can write it down here like this. That's 13 minus 6. What does that give you? 7. You've taken 1 from 2 there. So you've got 1 left here. You take another 1 here. So that gives you 11. 11 minus 7, that's 4. You've taken 1 from 5 already as well. So that's 4 over 4 minus 3. That's 147. So you can do the standard subtraction like you do using by writing it down like this. Okay, that's one idea. I 523 minus 376, this is how you could possibly divide it, possibly subtract it, right? So what you do is you take one there. So you've got one left here, and you have 13 here. 13 minus 6 gives you 7. And then once you have one left here, 1 minus 7 cannot be done. So you take 1 from this 5 there as well. So you have 12 there, 12 minus, sorry, 11 there. So you have 11 minus 7, 4. And then 4 minus 3 is 1. That's 147. Okay, now that's one way to do it. A lot of people are not able to do it for some reason when they're carrying things like that. Another way to think about this is in your head, do something like this. You have to go from 376 to 123. So convert the subtraction problem to an addition problem. Okay. So what you have to do is you have to go from 376 to 523. So think of it this way. What number do you have to add to 376 to get to 523? Okay. So from 376, what you can do is you can go to 400. In your head, what do you have to do to go from 376 to 400? You have to add 24. Okay, so you've got 24 there. And then what do you have to add to go to 500? You have to add 100 more. And then what do you have to add to go to 523? You have to add 23 more. 24 plus 100 plus 23, what's that? That's 147. And that's what you write here. That's your final answer. Okay, so a lot of times it makes things easier if you convert a subtraction problem to an addition problem like this. Make sense? Okay, now I generally do subtraction this way because that carrying thing is, again, not something that you can do in your head directly. You have to write it down. So it's often easier to think of it in your head, thinking of it as an addition problem instead, like this. Okay, so you think of how we go from 376 to something that you can easily do, like 400 and then 500 and then 523. Okay, all right. Now, what about this one? You've got minus, division, and addition. What has the highest priority? Division. You have to do this thing first. So you have 20 minus, as it is, 8 divided by 2. What's that? That is 4. And you have plus 1. And now you've got to go from left to right. Remember, minus and plus, they have the same priority. You cannot do 20 minus 5. That would be wrong. Okay? You cannot do 20 minus 5. You can't do 4 plus 1 first before you do 20, before you do the minus thing, right? You have to go left to right. Left to right. Okay? So 20 minus 4, what's that? That is 16. And then 16 plus 1, that is 17. And that's your final answer. You get 17 from this. Make sense? So for operations that have the same priority, go left to right. Is that okay? Okay. Was there any other question from this? Any other problem from the worksheet? Let me quickly scroll through this, because then in the next class, we're going to move to algebra. Okay, so yeah, so that's an important thing as well. Let me just go through that. So there are some squares and cubes. We talked about this in the beginning as well, that you need to remember. Now that is extremely important for questions like this, for instance. So square or cube, you can evaluate yourself as well, even if you forget that. For example, if you don't remember what 7 cube is, you can do 7 into 7 into 7 the exam and you'll get 7 cube. Okay. But what about square root and what about cube root? They are hard to evaluate. Okay. They're hard to evaluate in your head or by even writing them down. So you need to remember the squares and cubes so that you can do the square root and the cube root. So for doing square root and cube root, it is important. For example, you have cube root of 0.008 here. How can you do that? You can write it as cube root of 8 over 1000. right? We can do that. 0.008. We have 3 decimals. We can write that as 8 over 1000. And now we can do cube root of 8. Now you can only do that if you remember that 2 cube is 8, right? So cube root of 8 is going to be 2. Cube root of 1000, 10 cube is 1000. So cube root of 1000 is therefore going to be 10. And that gives you 0.2. And that's 0.2 as the final result. Okay, so you need to remember some squares and cubes. These are the squares and cubes that you should remember. And again, if you have to find a square or a cube directly, it's easy to do. But what if you had, for instance, cube root of 64? Now, it'll be hard to figure it out if you don't remember this. If you had square root of 256, for instance, you can get that in an all calculator paper. Okay, how do you do that? You remember that 16 square is 256. That is why this results in 16. You remember that 4 cube is 64. That's why this results in 4. Okay, now we just end with this. Remember, anything raised to power 0. So how do you evaluate squares and cubes? For that, let's think about powers. First of all, some rules that you need to know of. Anything raised to power 0 is 1, right? So 1 raised to power 0 is 1, 2 raised to power 0 is 1, 3 raised to power 0 is 1. Any number in general raised to power 0 is equal to 1. Okay. Any number raised to power 1 is that same number. So 1 raised to power 1 is 1, 2 raised to power 1 is 2, 3 raised to power 1 is 3. So if you have power 1, that's the same number. But then for squares and cubes, you have to remember some of them. And this is how they're generally evaluated. If you have a squared, for instance, that means a times a. If you have a cube, that means a times a times a. You have to multiply that number twice or thrice like this. For a square, you do a times a. For a cube, you do a times a times a. Okay? All right. Now, these are some squares that you need to remember. You need to remember that these are perfect squares. The numbers that you have on the right side, it's important. Okay? 4, 9, 16, 25, 36, 49, 64, 81, 100. And then 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. Until 15 is generally fine. But to be safer, you can remember these as well. 16 squared for 256, 17 squared 289, and so on up to 20. You've got 20 squared equal to 400. And after that, 25 is a common one. 25 squared is 625. And then 30 square, 40 square, 50 square, squares like these should be able to evaluate quickly, right? 3 squared is 9. So this becomes 900. The number of zeros becomes twice, right? So we've got 1 0 here in the square, you have 2 zeros. 4 squared is 16. So this becomes 1600. 5 squared is 25. So this becomes 2500. So these tens, you should be able to evaluate their squares quickly as well. And then in cubes, at least you should remember up to 5, at least. But ideally, you can do up to 10 as well. Okay. There's just a few after that, just 4 or 5 numbers. You can remember them as well. 1 cube is 1. So you need to remember that 8 is cube of 2, 27 is a cube of 27, cube of 3, 64 is a cube of 4, 125 is a cube of 5, because that will help you in taking cube roots. Okay. So 216 is a cube of 6, 343 is a cube of 7, 512, 729, and then finally 1000. So if you remember these, then if they ask you, for instance, what's the cube root of 125, you should be able to do this quickly, that this is 5. Okay, so you should memorize these. Okay, try to memorize these. The squares at least up to 15, and the cubes at least up to 5. Ideally, squares up to 20 and cubes up to 10. Okay, but at least first 15 from here and first 5 from there. This is what you must remember at any cost. Okay. All right, so that's it for today. And in the next class, we will be doing algebra. Okay. No, not this week, Fatima. Our next class is on Monday. In the next class, we will be doing algebra. But we will have 4 classes in some weeks. And in the weeks when we do have them, I will let you know beforehand. Okay. But this week, no, we don't have it. But in some weeks, we might have a class on most likely Friday. That might be an extra day that we do a class on. But when we are going to have that, I will be letting you know about it. Okay. All right. That's it
Allah
for
Hafiz, sir.
okay. That's it for today. I'll see you again in the next class in office.